let's learn something new. So this week we have Colby Abazs here with us. Colby is a part of the clean energy resource teams, So Colby grew up in an off-grid home. I loved this thing that you put in your bio about like needing to have a certain amount of like power to be able to watch a movie. So Colby has like a very unique experience with understanding energy and where it comes from and what it's used for. So we're really excited to be here to learn from Colby. Let's welcome him.
Okay, well, hello everyone. We'll see how this does with the whole podium thing. Usually I'm a person that walks around and uses my arms a lot, but for Zoom, we want to be able to have my pretty face on things. Well, I'm so happy to be able to be here. I think I presented here many years ago, back pre-COVID and all that. And so really excited to come back and hang out with you all and share food and tell you about the work I do with CERTs. So yeah, my name is Colby Abazs. I'm the Northeast Regional Coordinator, and so I cover Cook County all the way up to International Falls area and down to the Pine City area. So it's a really big region, and then CERTs itself is statewide, and so all throughout Minnesota, but we really try to be community focused by having a regional coordinator in each region. Let's see if the clicker still works. It does. So this is our talk here today. I hear we have to be done by 1. And so I figured like 45 minutes or so of me yakking at you. And then I'm anticipating you having lots of questions. And so I want to save some time at the end for questions and just any sort of tangents we want to go on. But definitely if you have questions as we go through the presentation, please jump out. And I want to make sure that I'm talking about things that are relevant to you and making sure to cover everything that you're here to learn about. So we're going to talk just real briefly about CERTs, a little bit who we are, what we do, and then the path of how to take an idea or an interest in clean energy to a complete project. So first you have to study, figure out what is the issues, what's going on, and then make a plan, actually what sort of project are we going to do, and then how do we pay for it? That's always a big one. And then finally you get to implement it and reap the rewards of that. And so really trying to walk you through all those different steps as I've run across in my work from taking a project from, oh, I want to do something clean energy to a finished product. And we here at CERTs like to support you in helping you get over each of those hurdles into that next stage of where you're at with your project. Most of this conversation is going to be focused on businesses and nonprofits. A lot of what I'm going to talk about today also applies to individual with some tweaking and stuff. And so could be things to think about for your own home, but the conversation today is mostly around organizations and nonprofits. So CERTs, Clean Energy Resource Teams, our mission is up there. I'm not going to read it because you can read it there, but for me, CERTs is really a connector. We're the ones that are out there working on a community level, trying to connect you and other people who have goals and interests in pursuing something related to clean energy with the resources and the people and the infrastructure to be able to do that. And so we're just that conduit trying to connect everyone across the state, across this region. And we have a regional coordinator, excuse me, as I said, in each region. And then we also have what we call our mothership office. There's some folks down St. Paul that have some of the more specialized skills in different areas of our work. So what's the path to success? First, what are your goals and priorities? That's the biggest thing that I always like to talk with folks about. And I do a lot of one-on-one conversations with business owners or nonprofit owners or operators that are wanting to get solar on their building or wanting to greenify their image. And so you really have to start somewhere as far as what are your goals and priorities, because that's going to guide a lot of decisions and a lot of different variables as you work further through the process. And then you have to figure out, well, we're talking about energy. How much energy do you use? There's a lot of different places and ways that you use energy. So you have to study that. And that often involves an energy audit. And then you have to plan a project. And so I like to think of this where it's you can't necessarily be oh, this is everything I want to be 100% clean energy by 2025. Well, let's start with maybe upgrading your heating to an air source heat pump. Let's start with what's a project, something that's tangible and focusable for that first step. And then have those other things in the wings, and maybe you cater that project to kind of set you for success later. And then how do you pay for it? These are investments in your organization. These are investments that are going to cost money. There are resources out there, and I'll talk more about that later in the presentation. And then implement it. And this, to me, feels like the easiest and the most enjoyable part because A, usually it means you hire a contractor to then do whatever the project you develop. So it isn't as much as like, oh, the first 4 steps are all very hands-on, very within your organization, figuring out what you want to do to move forward. And then the last one is we're going to just pay the person to put the solar on or to upgrade our heating or to buy an EV vehicle. And so you then get to reap the rewards of whatever project you're doing, whatever those may be. There we go. So why do clean energy? Does anybody have an idea? Like, why would you want to do clean energy? Anybody want to jump out with something that's important to you? Oh, we're such a quiet group today.
The earth is burning up.
Okay, the earth is burning up. So environmental concerns. Yep, that's definitely a really good priority. Anybody else? We got one. Broke the ice.
I was going to say cleaner conscience.
Cleaner conscience. Yep, that's a really good one as well. So there's a lot of kind of idealistic and values-based reasons. And then, yeah, another reason.
Cost return.
Yeah, lower cost, kind of thinking for that longer term scope, kind of return on investment piece. That's a big piece as well. And ideally, any sort of project you're working on is going to be hitting multiple of these different priorities or whatever kind of additional priorities you have. But it really is important to identify early on in the process, like what is your primary driving motivator? Are you doing it just because you want to be greener? Do you want to have a less negative impact on the environment? If that's your driving principle, you might design a project that looks a bit differently if your primary focus is on comfort or saving money or some other things. Likely, all those are going to be benefited by whatever project you do. You might tweak things a little differently as you go through that process. And then one that wasn't talked about was resiliency, which is sort of a co-benefit that often goes along with clean energy. When you're using less energy or when you're producing energy yourself, if you add storage, it's particularly resilient, but even if you don't add storage, that just increases your capacity as an organization to be able to continue to function in a changing world and be less kind of dependent and reliant on infrastructure that is continually getting assaulted by storms this winter. I know in my area, we've had several severe power outages this last winter. So that first step, get to know your energy. So you can do this yourself. A lot of times, if you're going to be applying for grants or loans later down for your project, you will need an energy audit by a professional auditor anyways. And so it's often well worth the $500 or so to pay for an auditor to do a comprehensive analysis of your energy use in your organization. And this centers around buildings or kind of infrastructure pieces, though it can include other pieces. And depending on who you get, there are different kind of nonprofit groups or organizations. There's called RETAP, Retired Professionals of kind of the energy space, and they do free energy audits. There's a lot of legwork you have to do on your end. So it's going to be an involved process with that, but it's really just about looking at really detailed, what do you use so you can identify where are those low-hanging fruits, where are those like really big bang for your buck, or where are those really kind of easy projects you can start with. So this is a residential bill, so a little simpler than most organizations will often have a much more complicated bill, also where an auditor or me can come in to help you navigate what that bill looks like. And this will be the core of what energy do you use. It'll almost always somewhere on it have a total kilowatt hours that you used in that given month. And then we'll often have a chart with kind of your overall usage pattern, which can be really helpful to identify like, oh, it's really high here. Why was that? And then it'll also have your rate or your price, which will definitely play an impact later on when you're looking at kind of the return on investment and the cost benefit of things like solar efficiency. It's like, how much are you currently paying for your electricity? So your bill, your utility bill is a really good place to start. Another really good place to start is to look at all your appliances, particularly the big ones, heating or cooking. any sort of appliances you have, and they should all have labels on them that say how much energy they use. And so these are a few different examples of different labels you can find on products or kind of on packaging for products that can help you to identify how much power does XYZ appliance or tool use. And then we got to look at the buildings, look at the infrastructure. Heat is a huge energy use. And here I'm not just talking about electricity. Maybe you heat with electricity, but a lot of us around here heat with propane or natural gas or wood. And so that's still an energy use. And so that's something, if you're looking at electrifying that heat, something you really want to look into. But even if you're not, that is a place where you could improve efficiency and or change fuels to something that's more resilient. Insulation is a huge factor of that. Some of it's just like the equipment of how you heat, but a biggest part is the heat that escapes. The less of that, the more heat you'll have in the building, the less you'll have to produce with your heat generation. Interestingly enough, as you can see from this diagram from the Building Science Institute, a lot of people think that most of their heat goes out of their ceiling. It's very intuitive. Heat goes up, some more heat. But actually the studies and the science that they've looked at, it's actually pretty balanced throughout the building as far as where the heat goes. And why we tend to put a lot more insulation in our ceilings is because that's a cheaper place to put really thick insulation. And so it's just kind of a bang for your buck sort of way to insulate. A little trivia fact there. There we go. And so particularly for commercial environments and farms and other institutions, you have other major loads that may apply to your situation. For farms, pumps are a huge user of energy and electricity in particular. And so that can be a significant use of electricity and energy. Any sort of motors, anything that's moving things or like doing a lot of work tends to use a lot of power. And then those in the commercial environment can also provide different advantages or challenges when you're looking to increase efficiency or looking to do solar as far as how that impacts your costs of a business. So there's a lot of simple things you can do, like just changing habits, changing when you plant, drip irrigation, how much water do you use? That's another thing where I like to think more than just electricity. Well, energy, it's not just electricity. There's a lot of other forms of energy, movement, heat, fuel. And so things like water, we don't think of water as an energy, but everything that we do with water takes a lot of energy. We heat the water, we move the water, we use it, we have to clean it. And so water actually is a really big contributor, and how much water you use is a big contributor to energy usage. And then vehicles. That's another thing that is less kind of building focused. But a lot of us, even if we don't have buildings, maybe have cars and we drive a lot for our work, thinking mostly in the nonprofit space. And so as far as kind of personal transportation vehicles, but also yard equipment, school buses, heavy equipment can now be electrified. And so there's definitely more and more options on the horizon. We have an electric tractor on my family farm now. It's really exciting and has wonderful co-benefits of it's quiet, it's not stinky, and all these lovely things. And it's electric, so we can power it off our solar power. And so electrification of vehicles tends to be a lot more efficient right off the get-go, and then also kind of sets you up on that pathway to then in the future produce that power from solar or other renewable sources. Any other questions about that piece of it? Cool. So now we're at step 2. Or was this 3? I've lost count. It's the next step of like, well, okay, we've got our values, we've got our ideas, we've done our study, we've looked at, I guess it's step 3. We've got our ideas, our goals. Step 2, we've looked at what our current usage and situation is. And this is a really case-by-case basis. So then step 3, we take that data, that report we got from the energy auditor, conversations you've had with me or with in your organization as far as like, oh, what is our energy situation? And then you apply it to be like, well, what's the projects we want to do first? Efficiency is almost always where I'm going to encourage you to start. You tend to spend a lot less money to get a lot more effectiveness out of it. And if your plan is to later get solar, efficiency means that much less solar you have to get to cover all your electrical needs. And so that's almost always a really good place to start. And there's a lot of great options. A lot of great opportunities for really easy things like LED lights. If they're like standard household lights, they're so cheap now, it's about a 6-month payback. So when I was going around my house and I'd like as lights burnt out, was replacing with LEDs. I did that math and I was like, oh, I'm gonna go around and switch every darn light out to an LED right now because the payback's just so quick. So there's definitely a lot of different low-hanging fruit like that, or the kind of more industry-specific pieces like efficient motors, different controllers or timing schemes as far as how you operate things, occupancy sensors, like in buildings like this, we'll have motion sensors so that they know when a room is occupied and can turn the lights on, but then turn those lights off when you leave. In business environments, there's also a specific scenario of like how you pay for energy. Often in business environments is you have demand charges, or you have kind of different rates of electricity for different times a day. And so that can really lead to some interesting ways that you can leverage clean energy to reduce your peak load, because you're paying a lot more for those kind of maximum energy need times. Yeah, question.
The solar used mainly to maintain battery power.
Well, it can be. So solar, and that's definitely a thing where a lot of times these days, solar doesn't come with batteries. You're just getting solar and you're basically using the grid as your battery. And we'll talk more in detail about solar systems later, but that's kind of the basic model of that. Under that model, when the grid goes down, you also lose power, even though you have those solar panels and it might be bright and sunny, but it's a safety factor for people working on those lines trying to fix why the grid's down, we can't have power feeding back. And that's where right now there is really great battery technology and the prices have been coming down a lot. So it's more and more possible and even financially advisable, particularly with those peak load shavings options, to incorporate storage into your system. So then you have that increased resiliency. When the power goes out, you still have power, at least in a limited capacity, and storage plus solar, then you can charge those batteries from the sun and theoretically have indefinite reserves of power. And so it's a really great mix if you're looking for kind of your specific situation and what your priorities are as well, as far as like, is resiliency a high priority, then batteries become much more viable as far as the economics equation. Good question. So in that same energy efficiency arena, heat, being one of the biggest users of energy, is also one of the biggest opportunities to conserve energy. Air source heat pumps, specifically cold climate air source heat pumps, can operate down to -5 degrees or colder these days. There's some that they're still in the labs at this stage, but can -20 degrees. And it's basically like an air conditioner, except it goes backwards. So it pulls heat out of -5 degree air and puts it into your house. It can be as much as 300% efficiency. That sounds impossible, right? How do you have 300% efficiency? But it's because it's moving the heat and not making the heat. And so this is a technology that we're really encouraging folks to look into a lot. There's a lot of really good rebates from the utilities and from the Inflation Reduction Act for air source heat pumps. They are a form of electrifying heat. And so especially around here where it's like, heat's kind of a requirement. When the grid goes down, we still have to keep our buildings from freezing. You will almost always, with an air source heat pump, need some sort of backup system for that -40 degree day. We actually don't statistically have that many of those in a year. And so your air source heat pump is, even up in this cold climate, able to do most of your heating load, depending on how you size and scale it. And having that 300% efficiency is incredibly great savings if you're currently heating with like resistive electric, like in a boiler or something like that. And it's still very significant savings on the efficiency and cost front if you're on propane or any sort of delivered fuel. Natural gas, it's a little bit more of a wash on the kind of economics front, but electricity tends to be a lot more consistent of a price. So at least your costs are more predictable, unlike around here where sometimes natural gas prices will spike right at the worst time of year when you need the heat the most. So heat pumps are a really exciting thing on the horizon, and that definitely applies to both residential and commercial situations. Yeah.
I just can't visualize these. Are there an apparatus that's outside of your house?
Yeah, I think my next slide's a picture.
Oh.
So this is one way that they can look like. Well, this is what's usually called like the mini split type variety, where it's basically got a condenser on the outside. This is kind of a residential size one. We can also get bigger block ones. So it just looks just like an air conditioner condenser, and then has the indoor head, You can have multiple indoor heads with one outdoor condenser, or you can have multiple outdoor condensers with multiple indoor heads. So there's lots of different ways you can configure it. And then you put those heads in different rooms, kind of determine where you want the heat. The nice thing with this is we're also getting hotter summers these days, and you get air conditioning. So it's like, A, you're improving your heating, and as a bonus, you get air conditioning, which I'll put my hand up. I get really unpleasant when it's over 80. I like air conditioning. And so, yeah, this is the mini split sort of style. There is also ways where if you have forced air, or even if you have like radiator type heat, you can kind of just plug it in as like a box in your furnace room that kind of feeds directly into your existing heating system. As far as when those are water-based hydronic systems, there's not a whole lot of products on the market yet for that, but all the big manufacturers are like 1 to 2 years out, where they're like, we're doing the final testing and getting ready for mass production, as far as it'll go from like -5-degree air to heat your water for your in-floor heat, or whatever sort of water needs you have. Yeah.
One of the Zoom
Participants is asking, doesn't this mini split heat pump have to be protected from snow and ice in the winter?
Yes, that is a really good question. Yes, it does. Internally, they have mechanisms built in to kind of defrost themselves on the outside, but you'll see this on a stand. This picture is obviously from more southern Minnesota, because that's how much snow they expected to get. So, but up here, you just want to make sure it's high enough. Sometimes they'll put them off shelves off your wall or something like that, so that it's not buried in the snow. And then often like under a little overhang, so there isn't snow piled on top of it. And so like, yes, snow and ice can interrupt its operations, but it can handle the cold, and it does have internal ways to help kind of deal with that, but it needs a little bit of help from us. Ooh, all sorts of questions about air source heat pumps.
So what happens when it's colder than -5?
That's where your backup system comes in. And this is again where kind of the goals and priorities are so important, because how you design your system, you can decide like at what temperature you want to switch to your backup system. Be that sometimes like if it's a big whole home or whole business condenser and air conditioner, they'll have the backup built right into it. Other times it'll be a separate furnace, or maybe it's the furnace you already have that's getting a little old and you're going to have to replace it in 5 to 10 years. You switch to an air source heat pump, suddenly that furnace is hardly working at all, and it lasts twice as long as it was expected to. And so you do still need a backup for those really cold days, or if an ice storm comes and totally sheets the whole thing over for a day or two. And that's where kind of figuring out what that backup looks like, and then also at what temperature you switch over to that backup. And that's where, if you're primarily economics focused, there's actually whole tables of like, at what price of your electricity versus price of your fuel backup, what temperature should you switch from your air source heat pump to your fuel-based backup? And so that's where, if your primary focus is cost, there's nice tables and charts for that. But if your primary focus is like using the air source heat pump as much as possible, you run it all the time, and then it just doesn't produce quite as much in those really cold times, and the other furnace has to help out a little bit. Yeah, another question.
Ground source heat pumps.
Yeah, so ground source heat pumps are the same technology. It's using the same practice of using pressure and kind of different fluids to move heat. The advantage with ground source is the source you're pulling that heat from is the earth, which tends to stay at a pretty stable 50 degrees. And so those can be as much as 600% efficiency. So they're a lot more efficient. The trade-off is they're a lot more expensive to install, because you have to put those coils in the ground. And another trade-off, the Finland Community Center, right in my hometown, has a ground source heat pump, and it works great. We love it. It's really hard to fix when it breaks, because there's only like one person in the area, and they're in Wisconsin, so barely in the area, that actually is maintaining those, because there's just not a whole lot of them around. And so kind of maintaining can be a challenge. That being said, particularly in commercial environments, if you have specific types of heat loads that are very predictable, and or if you have this physical space, this is more common in commercial than residential, ground source heat pumps can definitely be an option. There's just a lot more upfront cost, which is why we at CERTs are so excited about the air source heat pumps, because the barrier to entry is so low with those. It's just so much more. You can just plug and play, just like an air conditioner, just like an appliance. HVAC folks can very easily get trained in on these. So pretty much any HVAC person out there would be able to maintenance and kind of check it. Although we do recommend going with ones that are very familiar with cold climate air source heat pumps, because the ones that haven't, back in the 60s, they had what back then they called cold climate heat pumps, and there were lots of issues. Technology wasn't quite ready yet. And so then there's a lot of contractors out there that don't realize the technology is now ready and haven't gotten trained on it. Cool. So yeah, air source heat pumps, very exciting things. EVs again, there's a few different types of EVs. Give you some basic information about that. One is the battery electric vehicles, BEVs. Those are ones that just run on batteries. They have no gasoline or fuel-based components at all. And that's like the Teslas and some of the electric pickup trucks that have just come out. And then there's plug-in hybrid electric vehicles, which is basically like the Priuses and the other hybrids, except it has a slightly bigger battery and has a plug, so you can plug it in and charge up so that for short trips, you're only using electric. A lot of these will depend on what sort of your needs are in your business or your entity. If you have very limited vehicles, the plug-in can be a really good sweet spot because you have that gas hybrid motor that's super efficient, but does still use gas for when you need it for the long trips. But most people, most of their miles are less than 30 miles a day. And so most of those plug-in hybrids, if you like charge it at home, drive to work, maybe charge at work, or maybe just drive right back home, you'd be able to do most of your miles and all those miles on the battery and not have to use the gas at all. And so that can be a really kind of nice fit for that, versus the all-electric vehicles are a bit more upfront cost, but technology has come a really long way, and there's more and more models on the market. And so there's a lot of options out there, but needs a little bit more planning if you're doing a long road trip of figuring out fast chargers and other charging infrastructure. But the good news with charging is there's a lot of charging stations out there, and there's more and more being planned, being built all the time. There's a lot of federal and state incentives and dollars going to expand the charging network. And most of those chargers you'll never use, because 80% of the charging is done at your own home, because that's the most convenient thing of not ever needing to go to the gas station, because you just come home, you plug it in, and then it charges overnight. And so those fast chargers really just are for those road trips or kind of those longer trips. Yeah.
Is there, how do you find the information? Is there a website on the internet that shows you where you can find charging?
Yeah, there are several different ways you can find charging stations. There's several different kind of apps. A lot of the charging stations are within kind of networks of kind of who operates the chargers. So those will each have their own apps. There's some community apps and websites kind of map out. And that's where we got our map here. Tesla has their own system that's very tightly integrated into their cars. And so that's actually integrated into their mapping. When you like map a route in a Tesla vehicle, it'll find chargers along the way in the right spacing. Charging, as far as for those longer trips, can be a challenge as the growing pains, as this system gets built out. There are so many different apps and they're not talking to each other super well, or you like have to have an account with each app for their system of chargers. And so it's a little messy right now. I will be quite honest with that. But it is fast improving. And even like with Tesla vehicles, they do have like a plug adapter so they can charge off of non-Tesla chargers. And coming down the pipeline, Tesla is starting to add adapters on their chargers for non-Teslas to be able to charge off the Tesla vehicles. So it is rapidly improving, but we're still in that growing pain stage. Yeah.
Where do the charging stations get their electricity?
Yeah, they get their electricity from the grid, and often for those fast chargers, they use hundreds of kilowatts, and so those need a lot of grid power. The good news is around here, our grid is pretty green in Minnesota. We've done so well at achieving our clean energy standards, and so that's really exciting. And it sounds like, I don't actually remember if they've already passed it or about to pass the 100% clean energy bill, and so that's looking really promising as far as kind of the public charging. And then obviously like charging at home or at your business, that's where then if you get solar or if you kind of have other ways that you're getting clean energy for your operations, then you're getting it from clean energy there.
So if you've got solar panels, how much of that is taken up with charging a vehicle?
Yeah, electric vehicles use a lot of power. And so that's partly why, like, for me, I'm talking about all this now. And this part of like, this is when you should be thinking about this in the process of looking at your organization, what steps you want to take towards clean energy. Because things like an air source heat pump, if you're currently heating with propane and you switch to an air source heat pump, your electricity usage is going to go up a lot. And so that changes how big a solar system you might want. Same way, if you're planning on getting an electric vehicle and you're planning on charging it at your operations, that's going to use a lot of power. And so that's going to then increase how big a solar system you might want to build. And so it's like, there's definitely these kind of things where like, you want to pick a project to work on first and the focus your energy there, but you do want to be having those broader goals and priorities and that broader vision of what you're trying to work towards in mind as you're sizing those different pieces. And it's like, it doesn't mean you can't get the electric vehicle now, charge it off the grid power, and then plan to get the solar later, or get the solar now and then add on to the solar or oversize your solar in anticipation of getting electric vehicle later. So the order of operations isn't particularly necessary or dependence on your case, but definitely good to think about how those pieces all interrelate. Good questions. I love this, getting you all warmed up. So that's a wonderful segue into solar. We do a lot of solar stuff at CERTs, Clean Energy Resource Teams, because that's where there's a lot of interest, and the costs have come down a lot. So there's great access to being able to get solar and having it be economically viable. There's a few different ways you can do solar. I'm kind of getting to that battery question later. The most common is grid tied. You're connected to the power grid. Your power goes out when the grid goes down. Your solar panels work when the grid's up and help to kind of offset your energy usage. Other ways are kind of grid tied, but with battery backup. Often that's like a small backup that's maybe just got essential needs plugged into it, as far as like, if you're at the home, maybe it's your CPAP machine or your fridge or freezer, kind of those critical things, your furnace fans. What do you really need to keep running and power out? In a commercial and business environment, that's going to be so specific to your specific business needs, which is why we would definitely encourage you to reach out to experts, and/or we at CERTs will do kind of one-on-one consulting with business and organizations to kind of be able to do that minutia of your specific situation and kind of use our expertise to help guide that. And then of course there's off-grid systems like where I live, where you're not connected to the grid at all. And you have to design a very different kind of system, because I have to design my system to be able to meet my electrical needs on the shortest, grayest week in the winter. Let me tell you, that didn't work this last winter because we had a month and a half where the sun didn't shine. So I unfortunately used about 30 gallons of gasoline for my backup generator this year, which was 3 times as much as every other year. I try to put it in perspective. 30 gallons is like, well, 3 fill-ups of my little Prius car, but it's not that much gas in the whole scope of things. But now planning a much bigger solar system and much bigger battery that we're going to be installing this next summer. And so that's where you have to kind of oversize and over provision the size of both your panels, but also your storage for an off-grid system. Whereas when you're grid tied, you're able to kind of economize that and streamline that a little bit better, because you're able to use that grid as kind of that buffer to like help you out into those high needs, or to kind of in the summer, we have a lot of sun in the summer. And so we sell that all back to the grid in the summer. And then in the winter, you buy it back to actually run your loads. Nope. As far as kind of business and agriculture situations, there's a lot of really interesting ways that you can incorporate solar into the business you're already doing. A lot of these are still being researched. Not goats. I don't recommend having grazing goats underneath solar because they really like to chew on things, but sheep are great. And so that's definitely something that there is a lot of interest in doing this research, because, well, right now there isn't really prime farmland being used for solar. It would really be a nice co-benefit to be able to have that solar and be able to still use that land underneath it. Obviously up here, we don't have huge fields. We're not doing those large systems as much, but it can still be nice to think about like, oh, I don't have to just have it be gravel or pavement or some kind of yucky fence around my solar panels. I could have it be a flower garden. I could have it be pollinator habitat. Could incorporate it into the broader mission and vision of the company. So if you're looking at solar for your organization, bunch of big things you have to think about. How old is your roof? Solar lasts 25 plus years. And so you don't really want to be putting that on a roof that's going to need replacing in 10 years. You can take the solar off, replace the roof, put the solar back on. It's just a lot of extra hassle and expense. And so maybe that's when you look at a ground mount, or you look at, let's maybe replace the roof a little sooner or switch to a metal roof, or other ways to kind of have it integrate better into solar. Solar will, however, help extend the life of your roof because it's providing shade and protection. Obviously facing south is very important. You can get plenty of energy east and west, and some people even get it from facing the panels north. You just don't get as much, and so the economics aren't quite as favorable. But the good thing is panels are cheap enough that if you have the roof space, you just put more of them and you can still meet your energy needs. Another thing is just owning, especially for kind of nonprofits and stuff. If you're renting or using a building that's kind of under some other form of ownership, that doesn't necessarily mean you can't do solar, but it certainly complicates the situation as far as working with the owner of the building, and or do you own the solar? Does the building owner own the solar and then sell you the electricity, or it just complicates the situation, which is again why in my discussion today, I'm really trying to give you the high level, the broad kind of topic so that it can perk your mind and get you thinking about this and coming with those questions, and then reach out to me and I'll hand out business cards later. And we can definitely talk about specific situations that you have and really provide that one-on-one to your specific needs. So here, I didn't want to talk too much about sun because I have this wonderful graphic. We have lots of sun here in Minnesota, partly because we tend to have a lot of clear days in the summer. And we actually have really long days. And so our production is very summer weighted. That works fine when we're using the grid. It's a little more challenging for off-grid because our highest need for energy is in the winter for heating. So that's where kind of grid intertie is what makes the most sense for most people's situations. But we have plenty of sun potential here. It averages about 4 hours of full production per day. And that's definitely something that your solar installer, whoever's kind of designing the components of that system, will factor in not only hours of day, but also weather patterns to kind of model out how much realistic energy production you'll get from the solar system. So up around here, we tend to have a lot of space. We have a lot of trees too, and we might not want to cut those trees down. But particularly in the commercial environment, it's worth considering looking at ground mount systems. They have a lot of pros, especially with the snow, because ground mount, you can fairly easily brush the snow off of them to keep getting production through the winter. That's a lot harder to do when it's on a roof. The good news is, like I was talking about with the sun, we get most of that in the summer. And so if your panels are covered by snow for even a couple months of the winter, you're not actually losing that much of your total annual production from the solar. Usually when I've talked to installers, they estimate about 20% loss due to kind of snow coverage in the winter because so much of your production is in the summer. And so it's not the end of the world. If your panels are covered in snow in the winter, we're hardly getting any sun anyways. So, but ground mount, obviously you can remedy that issue. And it's sometimes a little bit more expensive to get installed just because if they need to do kind of assessments of the soil stability or kind of other factors, the mounting hardware can be a little bit more expensive. But it can have a lot more benefits as far as not needing to worry about your roof, not needing to worry about is your building structurally strong enough to hold the weight of the solar panels and kind of that whole apparatus. So when you have the space, worth looking at ground mount. Any final questions about that stage of planning for your business? Yeah.
The pitch of your roof. That plays a big part into it. And if you did get a heavy snow, are there any heaters or whatever in the solar panel to?
Yeah. So pitch of your roof will have a significant impact on whether the snow sheds or not. If you're looking at like a residential pitched roof, if it's steep enough, it should shed. If you're looking at a commercial environment, you're often on flat roofs and they're kind of ballasted and stacked on those. Those, even if they could shed, there's usually nowhere for the snow to go because we get so much of it. And so that's more challenging unless you're going to shovel it all out of there. But like that seems like a lot of work for how much missed opportunity of sun you're getting. But definitely a good pitched roof and a good angle roof. Obviously, that southern exposure really helps. As far as the second part of your question is heating or ways to kind of help slough that snow off. There are a few experiments and tests that have been done as far as like putting heating elements into the solar panels. The problem is making heat by electricity uses a lot of energy. And so like the kind of return on both the cost and complexity, but then also just the energy used to heat and slough that snow off versus how much energy you get from them now being uncovered. It's been really hard to kind of quantify and show a good value proposition for that. A lot of times it's just mechanical as far as getting a snow rake up there, trying to kind of help it along. A really nice thing with solar panels, they produce heat when they're operating. And they actually are more efficient when they're colder. And so that's probably why we're such good production here, because they tend to be colder. And so they're not overheating, not lowering that production. But that for as far as snow sloughing goes, that means that as soon as a little bit of the panel is clear, the sun will hit that part and warm the panel up, which helps to clear the rest of the panel. And so definitely like as far as ground mount and like for me off grid, it's mandatory that I clean off my solar panels. It's like I'm able to clear them off and keep them clean throughout the winter. And then it's obviously if that's lower priority, you're connected to the grid, then it's like, yeah, you do it when it makes sense. Good question. Yeah, another question.
Oh, you go ahead.
Well, this is changing subject.
Oh, okay.
Oh, okay, we're on solar.
So, how does it work if you have solar panels and wind power? Like wind in the wintertime is a little bit thicker.
Yeah, so solar in combination with wind. That is how my farm initially did it, because the idea is when it's less sunny, it's probably more windy. It sort of worked. Wind is a lot of maintenance. Solar is amazing. You set it and you forget it. And it just does its thing. And like, yeah, maybe a little bit of cleaning snow off in the winter, but it's like, it's really low maintenance, low attention needed. Wind, especially small wind, ice build up on the blades and they'd start rattling. If it's too windy, then you have to turn it off in the middle of the windstorm. And so childhood growing up with this one bright flashlight, and we'd have to wait till the wind calmed down enough for it to slow enough to like hit the brake and hope it would stop. And if it wouldn't stop, we'd have to shout them like, it didn't stop, and turn it off so it didn't blow something up. And so wind is just, yeah, if you're looking at large scale wind and like the towers they have up in Mount Iron and stuff, like that's a different picture. But as far as like for a business or small operation, small wind, I discourage strongly. Yeah.
So, thought about putting solar panels on the lakes in the winter with just drilling holes and put a through the ice. Does that sound real dumb?
Putting solar panels on water, it has been explored, mostly in the context of like waste ponds, because we have these big open areas, lots of sun in a potentially dense area. And so like floating solar has been explored. It's still very much in the experimental stage, like logistically and like technologically wise, like why not? It's more of just the practicality of like, does this make sense? What are the advantages versus the disadvantages and the economics of all that? And as far as the ice, the problem is seasonal. And so just like the whole, like all the work that it takes to get something set up. And then it's also the time of year when we have the least sun production. Where are the panels when they're not being used on the ice and in the winter? And so there's a lot of those different things. There are some people experimenting with that. But as far as like the bread and butter of like what we know works and can kind of be economical and feasible, I don't know. It seems like a lot of extra work for when what we have already works really well. Yeah.
How much the average family waste on like those electricity for appliances like they're plugged in but not being used? Like my toaster is plugged in.
Yeah. Yeah. So phantom loads, as far as kind of as part of your whole energy consumption, it varies a lot depending on what sort of technology you have. These days, I haven't seen as much of an issue with like really high phantom loads. Like back in the day, it was like a propane cook stove would use 30 watts to keep the clock running. Nowadays, when like I have a watt meter that I'll plug in and plug an appliance into, And it's like, yeah, there's a lot of appliances that'll draw like half a watt just constantly. And so like, yeah, if you got 100 of those, they do add up. But I think the bigger kind of phantom loads and hidden loads are actually computers and like IT and electronics. Things like your router, that's using 20 to 30 watts constantly. And so especially in a commercial environment, if you have a lot of computers and they're just kind of left on, or a lot of IT infrastructure, that should definitely be a part of your audit and part of your analysis of what your energy load looks like. Definitely still a great idea to put things on power strips, still a great idea to use watt meters and check how much things are using when they're off, to catch any of those really bad players that might still be hanging around. But as far as most modern electronics, they're pretty good at going into a low energy mode and not idling a whole lot. So, yeah.
You've talked about the grid a lot, which I assume that predominantly refers to things like Minnesota Power or
Yeah.
those. And so with solar panels, you're either feeding into it or drawing from it. Do you know anything about places where you're not directly connected to that supplier? Like Ely's one of them, where Ely buys its electricity from
So kind of,
and then if you end up hooking up with your solar panels, you could either be entirely off the grid, probably, or how do you connect through a secondary supplier? That's what
so it sounds like you're asking about kind of that whole interconnection process with a utility when you're getting solar, particularly in the more complicated state, as we have so many utilities in my region. Like other regions have like 3, and I have like, I don't know, I can't count them, there's too many, where it's like, yeah, you've got the co-ops and the municipal utilities that are buying wholesale from somewhere else. And that actually is a perfect segue into the grants and financing piece, because the first, well, other than just the intro, which I'll get to that right after this slide. So basically ways we can help. We have a whole program and we have a grant that we got to help support businesses and organizations implementing these clean energy projects we're talking about. So we can do solar site assessments, or we can look at if you had a solar contractor come out or had an architect kind of put together a plan, we can look at that and be that third party. We have no money in the game. Well, like here, you should ask them about this, or like this assumption here is like not industry norm, or because sometimes like people are kind of fudging the numbers to make them look well. And so we can either kind of do solar site assessments and financial modeling for you, or look at models you already have. We can support you in applying for different grants and financing, and then doing information sessions like this to help just provide you with that general information to be successful in the project. So, yeah, question.
I think most of us here are not part of any organization that's going to be looking to put solar on the roof or whatever. Does your organization confer with individuals?
Yeah, so that's a good question of who do we support? CERTs works to support kind of community-wide entities. And so as far as like direct one-on-one support, we mostly do that just with organizations and businesses, just out of a capacity limitation. As far as individuals, like, yeah, if you give us a call and I got 10 minutes, I'll talk with you and happy to answer questions and help you as I can. We have a lot of really great resources on our websites. And there's a lot of really good information out there, and I have handouts with me if you want to bring some. But yeah, as far as like individuals, we don't do a whole lot of work, and we'll refer you to solar contractors and installers and other folks that are well-versed in how to kind of size and figure out what system's right for you. And then definitely general info through things like this.
I mean, raise your hand if you have been involved with a nonprofit organization in the region. Okay, I thought it was gonna be more
yeah, and that was one thing that came to mind when I was coming here, and I was like, yeah, I mean, you're maybe not currently running organizations and businesses, but I feel like you're the kind of folks that have fingers all throughout the community. So I'm hoping you'll bring everything that you've learned today to the businesses you patronage and the organizations you're involved with and volunteer with, and maybe start conversation with them and have them reach out to me. And so I'm happy to work with them and talk to them directly. And I have handouts that you can bring with you. Be like, oh, I'm going to bring this handout about our kind of renewable energy for Greater Minnesota program to XYZ business. So lots of questions. I'm running a little short on time, so I'm going to try and jump ahead a little bit so we don't miss out on too much of this part. So utilities are definitely a good place to start. They have various different rebates to help you be able to kind of do energy efficiency and solar projects. And oftentimes that is through your local utilities. So like Ely Municipal Utility has their own programs. Sometimes that is partly through your wholesaler, in this case, Minnesota Power. Net metering is the main rules that define kind of how people connect their solar to the grid. And the nice thing with net metering is that it basically obliges the utility to buy the power, the excess power that you produce at the same price they sell it back to you later in the year. Usually there's a true up period every year or whatever that's like, oh, we produced this much more than we used over the whole year, and then they'll reimburse that amount at a lower rate. That's usually the cost offset rate or the wholesale rate, which is much lower. But as far as kind of, oh, I'm producing extra in the summer, I'm going to sell it back, and then in the winter, I'm going to use that power, that's done at the same rate when in the net metering program. Depending on whether you're a co-op or municipal utility or Minnesota Power would be the only investor owned around here, or there's slightly different rules about what qualifies as net metering. If it's under 40 kilowatts AC, it's net metering. If you're in Minnesota Power, you can go above that 40 kilowatts as long as you stay within 120% of your expected annual production. And then there are different kind of rules, and there's a whole application process with the utility as far as actually doing the nuts and bolts of connecting your solar system to the grid. And that's something your solar installer will handle it all for you. But it's always good to talk with them early because you want them on board. So solar incentives, the Inflation Reduction Act has some really great incentives for solar. The bottom line for businesses is 30%. And then there are some add-ons if you kind of get made in Minnesota or made in the United States products and kind of disadvantage or lower income communities and other things like that. So that can really help the finances pay back for an organization. And really importantly for nonprofits, they're adding a direct pay option. So if you don't have any tax liability, there will be a way for you to still reap that 30% reward. That was a huge part of the Inflation Reduction Act and just broadening who has access to that money. Oh, I'm not going to try and say that acronym, but basically there's fancy ways you can depreciate the asset. This wouldn't apply for nonprofits because you don't pay taxes, but for a business, you can write off the expense of the system in an accelerated way that can, depending on your tax rate, be a pretty significant amount of savings and how much taxes you would have otherwise had to pay on that income. And then up around here, we've got IRRRB. They've got a business energy retrofit grant program that can cover up to 20% or 20%, no, third of your project up to $20,000. Excuse me. So many different specifics of all these programs, which is why this slide will be up later for you as well. And you can definitely reach out or find info on their website with their details. That's a really great program. And USDA has rural development REAP grants. And so that's one that there's actually an application coming up in March, the end of March. We're really trying to get all their money out the door. They're like, we want to prove them wrong that we can get all this money out the door. So if you have an entity that might want to do a project, have them reach out. We'd love to work with them and get them ready to do an application. They're pretty involved applications. They can cover up to 40% with the Inflation Reduction Act. That got increased from 25%. And it's rural ag, but it's also small businesses in rural communities. So basically anything outside of Duluth or the Twin Cities. And they have a pretty involved application. So we recommend you hiring a grant writer because I did a whole walkthrough in that application. It looks like a headache. And we do have a list of grant writers that are familiar with this specific application that we can direct you to. So yeah, why fight the forums when you don't have to? PACE, Property Assessed Clean Energy, is a really great way. It's a loan option but it's designed to be a kind of cash flow neutral, because cash flow can be one of the biggest concerns in a business environment. And so they actually assess the kind of payment of that loan on your property taxes. You're not paying property taxes like with a nonprofit, you can still get a special, so you would get a tax bill just for this special tax assessment. And so that can be a great way in combination with REAP or IRRRB to kind of balance the matching dollars that you need for those grant programs.
What's up with like chain? I mean, it's not green. And stuff.
Ah, yes. The green ones are the ones they have this option of doing PACE funding has to be approved at a county level. And so those light colored ones haven't done that yet. But really, we help with that. And we've helped all these counties get on the PACE list. Usually the best way to do that is have somebody that wants to do a project in that county, and then we'll help them work with the county to get it approved. It's a thing that they do. It's pretty easy for them to do. They just need a reason to. Yeah, good question. PACE fine print stuff. Own your building is the biggest part for that. Let's go with that. Almost complete. So we do have a guide on our website of finding solar installers to help with that piece of kind of actually then implementing a plan once you know how to pay for it. And then some lovely stories that I'll leave you with. Yeah, last question. Yeah, for residential, it's going to vary a lot. A standard home is like about 7 to 8 kilowatt size system. For residential, you're usually looking at around $3 per watt. So you're looking at $25,000 for a residential system. Commercial, it's so variable. But give you two specific examples. These are both farms, so this is kind of just how it worked with one system. So this is about 10 kilowatt system that was on this farm. And then all the kind of the full cost, 50,000. This was obviously a few years ago. And then kind of all the benefits and tax write-offs and grants and such that then actually got to that bottom line of what are you actually paying. And then here's another system. So give you an idea of at least on the commercial to options for all the incentives. But yeah, it is a significant investment. The nice thing, particularly for like commercial or public entities, is it fixes your cost. Like it basically sets that I will be paying 8 cents per kilowatt hour for the next 30 years on my electricity. And you're paying that up front, but it really locks things in, which can be really advantageous for budgeting. And I know for a lot of nonprofits in particular, it's a lot easier to fundraise or get grants for capital things than for ongoing costs. So to me, that seems like a really good fit for solar as far as gather that money to actually do the project, and then you save so much money in the long run, and all those ongoing costs are much harder to fund. One last question, and I think we're out of time.
That's when you're on grid, so that particular system?
Yeah, I think both these systems are on the grid. Most systems are on the grid. If you're adding batteries for off-grid, that will significantly increase your costs. It's usually the contractor. Usually whoever's installed, it comes with a maintenance contract for at least a portion of it. And warranties are often, like workmanships, usually at least 3 years to 5 years. And then for the materials, it's usually a 10 to 25-year warranty, depending on the product and the type of warranty. So check out our website, reach out to us for more info, get bids. Yeah, that's me. Thank you. You had so many great questions. We used up all the question time in the middle.